Apis. Apis. So up to simple index completed now. Simple index. Now take next one. Composite index. Composite index. So in this composite index, okay, how and what is the mean by composite means? Composite is nothing but multiple. So whenever we created index object on multiple columns, okay, then we called as what now? Composite. Okay. So write down. When we created an index, an index object, so based on multiple columns, based on multiple columns. So we called as composite index. The syntax of your index here, create index, and I want to give it index name on table name of a column name. So your multiple columns, you can see column 1, comma, column 2, comma, and so on. But now here observe. So when I was given here multiple columns and based on multiple columns wise, if I prepare my index object, then which column wise index can be work? Okay, out of these two columns, which column wise index will be working means indexes are always working, okay, based on leading columns. Okay, now, so leading means first column. So it always working on leading column wise. So leading column, which column are you given here? Okay, that is your first leading column or first column or leading column. And remaining columns are called as a non-indexed columns. Okay, na? So that means we created index on two tables. That's okay. But indexes can be activated when we use leading column only. Okay. If non-leading column, if I use it, the indexes will never work. Okay. So here below, take one note point. Indexes are working based on leading column wise. Okay, and I'll come to examples now. So this is your table. And on this table, on which columns we applied your indexes, that I can say. Columns where table underscore name is equals to EMP. So present on this EMP table, we created only I1 index, on which column we created salary. So this is what it was. And now I'm going to create one more index here. Create index I2 on table name EMP of suppose department number, comma, job. So here I'm going to create my index object on multiple columns, department number and job. So in this two, which one is my leading column means department number is called a leading column. So which column are you given in the position of first position? That is your leading column. And this column, when I use in my where class condition, then only indexes can be work. Okay. So now I'm going to create it. My index will be successfully created. But after that, when you return your query, select a star from where DEPT number 10. So indexes are working. Indexes are working because it is a leading column, and that leading column I'm using under where class condition. So indexes are working to retrieve your data. Next, if I want to write here, select a star from EMP where, okay, where job is equals to, suppose I was given here and list. When I was given this, and so many people, what they think, job is also one of the indexed column. So that means the people will thinking that this is also working on index basis. But the thing is, here, job is not a leading column. So when I'm going to retrieving data, okay, based on non-leading column wise, so what it was happened, internally it was perform what now? Table scan. It doesn't perform index scan because in this where class condition, I don't have any leading column here. So I'm just taking here non-leading column wise. The data can be retrieval. So whenever you want to retrieval non-leading column wise, then indexes will never work. And internally by default performing default. What is that? Table scan. But when I'm going to writing here, so department number is equals to 10 and job is equals to, I was given here clerk, for example. Okay. So when I'm using the two conditions here, okay, but in this two condition, I was used what now? Leading column also there. So when leading column is also there under where class condition, then definitely it was perform index scan. Okay, na? So this is composite primary key internal working. So when you have a leading column, then only indexes will be activated, otherwise not activated. Okay, na? Right on below. Okay. And next, the third one you can write unique index. So what is unique index means? So whenever we created our index, okay, when we created an index object, okay, so based on unique constraint, based on unique constraint. Okay, so then we called as unique index. And unique index, what it will do, guys, here, we all of you know, the unique constraint purpose is what now? Restricted duplicate. So to restricted duplicate values. Okay, automatically your searching time will be reduces. Understand now? For example, okay, the first I will give it a index syntax here. Duplicate values so that it reduce searching time. It reduce searching time. Okay, what is the syntax of this? So create unique index, and I want to give here index name on table name of column name. So here, for example, if you want to see, suppose one of my columns serial number and another column SR number. On SR number, I was applied a index, unique index was applied. But on serial number, there is a no index. There is no unique constraint. Then what it was happen if I was given 1 and 1, if I was given 1, 2, if I was given 1, 3, if I was given 2, 4, next 2, 4, 5, next 3, okay, so next 3, next 4, 4, 4, 5, 5. So in this 2 columns, how many numbers I say means only 5 numbers. So 1, 2, 3, 4, 5. 5 digits are we saved. But here advantage is what now? We have a unique index on this column. That's why unique constant nature is what now? Duplicates are not allowed. So every serial number should take as a uniqueness. Okay. So 5 unique numbers. But here the same thing, serial number. But here the unique constant was not there. That means your unique index is not there. If it is not there, there is a chances to occur so many duplicate values. But here also I saved 1 to 5. Here also I saved 1 to 5. But here how many times the numbers are having here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But here 5. Suppose if I'm going to writing my query, okay, select star from so-and-so table where serial number is equals to, if I was given 3, then what it was happen for this condition, okay, purpose. And first of all, you can see serial number column is a indexed column or non-indexed column. Non-index. Non-index means there is a no index on this column, right? If there is a no index means as per this condition, what it was happen? Table scan is performed. So table scan is performed from the top to bottom. That means how many numbers searching? 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So your searching was how much here? 12. 12 rows are searching here. Okay. 12 rows are searching here. But the same thing, if I'm going to writing for this, okay, I'm writing like a select a star from T1 table where SR number is equals to 3. Then how many searcher? Only 1. So that means as per row ID, directly jump to 3. So these are not searching. These are not searching. So that means the 4 rows are not searching. Okay, now. So your time is what now? 4 seconds will be avoided here. And within 1 second, I got it my output. But here, 12 seconds. To take your required data purpose, 12 seconds. Okay, but here, that means 4 seconds is reduced. 12 minus 4, that means how much here? 8 seconds time will be save us. So because it's a very simple logic, when you have a more duplicates, automatically searching time will be more. If you have a less duplicates, then automatically searching time is less. So this is what advantage of your unique index, right on below. Okay. Now, don't write. This is just your idea purpose I was given. And now let me come out and see how to create it here. For example, okay, one of my table. So select a star from DEPT. Okay, on this table, now I'm creating my unique index. So index UI on DEPT of D name. Okay. Now, so my index name is what now? UI. And suppose this index you want to see whether it is created or not. Okay. So here I want to see my data dictionary, and unique index was created on department name column. And now after created this unique index, okay, now I'm inserting into DPT, sending values of 50, comma, sales and HYD. But I already on my department name, sales already there. And now I try to insert it what now? Sales. So, but already existing your sales name in your table. So that means it was accepted or not accepted? Not accepted. And see, it was showing unique constraint is violated. And what is your index name? UI. So I already said to you, whenever you applied unique constraint on a table, automatically system is created indexes. And that was explicitly if user want to create then this is your syntax, how to create a unique index on particular column. So that means what you understand, the previously also, when we are discussing with constraint concept in the previous classes, so there also indexes are created, but there I didn't expose this. Okay, I didn't tell you, but now I'm going to tell you. So whatever, when you applied unique constraint, automatically indexes are created. And based on this indexes, what it was happen? Okay, searching time will be reduced and they quickly can retrieve your necessary data. Because of reason, unique constant advantage is what now? Duplicates are not allowed. When duplicates are not there, automatically my searching time also very fast. Okay, so that is the advantage of your unique index. Okay, right on below.
ఆయన 120 kilos. మళ్ళీ కింద క్లాస్ మన లోపల అంటే ఈయన తొందరగా వదిలేదు. వెంకటేష్ మాస్టర్ గారు 50 kilos ఆయన కానీ ఆయన వచ్చేసరికి టైం పడుతుంది సార్. 11, 10, 11, 20 kilos అక్కడ నుంచి ఇక్కడ
ఇక్కడ చేస్తాను ఆయన చేసుకుని నా కాలంలో ఆయన చేసేసి సైడ్
అవునవును సార్.
ఈ సైడ్ స్టూడెంట్స్ అందరూ వెళ్ళిపోతారు చేసేస్తారు. ఎందుకంటే మన మ్యాచ్ అందుకని టెన్షన్ కూడా ఆయన ముందు ఇచ్చేసాడు. నేను అక్కడ పెట్టేసుకున్న ప్రశాంత్ ఆయన తెలియదు, నేను అక్కడ ప్రశాంత్ సరిపోతుందా ఈ బ్యాగ్ లోన్ పెట్టేసాను. Okay, right. And the next one, take extra functional based index. Functional based index. So when we called index is a functional based, means when we created an index object, okay, so based on function name, based on a function name. Okay, so then for example, I'm using here the syntax was create index and I want to take my index name on table name. Okay, in this column first you have to use function name of column name. Okay, so this is called as a functional based index syntax. And here as per your requirement wise you can give any function name, and already we discussed so many functions in early classes. Okay, now so any function you can use here on particular column. Okay, right. And for example, let me come out and see our table. This is my table EMP, and now I'm creating one functional index. So create index I number 3 and on EMP of for example, I'm using here my function is upper of a name column. Upper function means what? It was lower values converting into uppercase. That means finally upper function will return upper characters. Yes or no? If you send lower characters, that was converting and send back uppercase characters. So upper functions always return uppercase characters only. Okay, right. So now I'm going to execute it. My index successfully created. But whenever you want to retrieval this, suppose I'm retrieving, select a start from EMP where the condition is what now? Okay, I'm using upper of a name is equals to, I'm giving Smith. Upper of a name is equals to, I'm giving Smith. Okay, now I'm giving Smith. Now see, my condition is which function? Upper function. So that means your name should be in the format of uppercase. The name should be in the format of uppercase. But are you giving lowercase? So now upper name, that means uppercase characters. Suppose your table name is uppercase Smith. Smith is equals to small here. Okay, na? So small case Smith. Smith is equals to Smith. So here condition will be true or false? False, because here it is uppercase, here it is lowercase. Uppercase is equals to lowercase. Condition matching or not matching? And see, when in your table also, which case character? Uppercase. But here I'm giving which case character? Lowercase. So now it was not matching. When it is not matching, data will not retrieval. Okay, now? Because whatever the user was applied the condition here, the condition character values are lowercase, but my condition column is uppercase. So condition of data is not matched here. So that's what it was happened. Indexes are activated or indexes are not activated. Indexes are not working here. So now I want to give it. Now condition is true, indexes are activate and data retrieval. Okay, now right, Amul. Okay, so these are what now the B-tree indexes, different formats and different way of conditions. When we are using function, functional based index. When we are using unique constraint, unique index. When you apply it on multiple columns, composite index. When you apply single column, simple index. Okay, now? So different conditions wise, we applied and created indexes. Okay, right. So this is B-tree. Okay, and B-tree indexes are called as what now? Default indexes we call. If any interview person, he will ask you, okay, which one is a default index means B-tree indexes are called as what now? Default indexes. In these two indexes, which is default means B-tree. Okay, and different conditions wise, different types of indexes are we created. Okay, so this is what B-tree index. And what about next bitmap indexes here? And these indexes, okay, on which type of columns we are creating, okay, and how it was working here. Okay, now you can come out and see. So bitmap index. Basically, these indexes are created on low cardinality of columns. Okay, bitmap indexes on which type of columns you need to create means low cardinality. Okay, na? So created on low cardinality columns. Cardinality columns in a table. Okay, na? Now, so but here the question is, what is cardinality, sir? What is cardinality? So here cardinality is nothing but, okay, what it represent means it refers the uniqueness. Okay, na? It refers, okay, the unique or uniqueness values of a column. Uniqueness of a or uniqueness values of a column. So in a particular column, okay, what it will check here, how many unique values are there. Okay, na? So based on that uniqueness values of a column, it will be calculated your cardinality. But how to calculate my cardinality of column means there is a formula. So what is the syntax here? Okay, to finding cardinality of column means cardinality of column is equals to number of distinct values, okay, by distinct values by number of rows in a table, number of rows in a table, number of distinct values in a column by number of rows in a table. So here, what is the mean by distinct? Distinct means duplicates are counting or duplicates are not counting? Not counting. So duplicates are not counting. It means that what it was counting, which type of values are counting? Uniqueness values are counting. Yes or no? Distinct keyword, what we discussed in the early classes, it was avoiding duplicate values. So duplicate values are eliminated. Okay. So eliminated means those values are not countable. Okay. And which values are countable? Uniqueness values. Uniqueness values are countable. Uniqueness means what now? Different values. So whatever the different values are there, after eliminated my duplicates, whatever the remaining unique different values are there, those different unique values are counting. That's called a distinct keyword. Okay. And later, what next I need to find out? Number of rows in a table. So distinct values in a column by number of rows in a table. Based on this, we can find out what now? Cardinality of a column. Okay, for example, first understand. First, I need to find out here. Okay, so cardinality of a EMP number, suppose I need to find out. Okay, so that means before I need to apply the bitmap index on this column. Okay, that means if I created bitmap index on this column, then my performance wise improve or not. Okay, na? Before you want to check that, first of all, what the people will do on this column, they will be finding cardinality. So how much and what is cardinality of a EMP number? So like this, when they use and when they try to apply bitmap index on your column of a table, then they will choose which column is a least cardinality column, because what we said in the definition, bitmap indexes are created on low cardinality of columns only preferable. Because on low cardinality of columns, if I created my bitmap index, then database performance will be very good. That means performance is very high and data accessing is also very, very fast. But on low cardinality of column, if I'm creating B-tree index, then it will take somewhat time consuming process. Okay, na? So that's why bitmap indexes where you want to prefer to improve the database performance and to retrieve your required data very fastly means when the column is having low cardinality. Okay, low cardinality of columns don't prefer B-tree. Performance wise, not good. So that's why the people, what they will prefer? Bitmap. Performance wise, very good. Okay, na? So then B-tree indexes where you created means B-tree indexes are created on high cardinality of columns. Conclusion I'm giving lastly after explaining this. So simply what I'm saying here, your column cardinality is high, then apply B-tree. Performance wise, very good, suitable. Okay. But when column cardinality is low, use a bitmap. So these are the two scans how they can choose, okay, the people on this column, bitmap is suitable or B tree is a suitable. How they knows means that real-time programmer is going to be finding cardinality of column. Suppose EMP number column I'm finding. So this EMP number column cardinality is high. If it is a high value will come as, then they will prefer B tree indexes. If this column cardinality will be low value, then prefer bitmap index. Okay, that how it is. First I will explain to you, then you will get some idea. So cardinality of EMP number I need to calculate. So cardinality of EMP number is equals to what I need to find out? Number of distinct values in a column. In which column I have to find out EMP number? Can you come out and see? In this EMP number column, I want to know how many distinct values are there. Count. 14. Do you have any duplicates? All are unique. All are unique means all are unique values, uniqueness values. So uniqueness values are countable. So how many are there? 14. I just keep it. Number of rows? 14. Finally, 14 by 14, how much? So that means cardinality of EMP number column, how much? 1. Okay, I just keep it this. Now, next column you can check. Suppose I want to create a cardinality of E name. In this table, I'm saying that. What is your cardinality? 14 by 14 means again cardinality is 1. I just leave this. Next column we can check. What is this? Now I need to find out. I need to find out now. Cardinality of which column? Job. Now in this job column, can you see how many distinct values are there? How many? 5. What are those? Clerk, salesman, manager, analyst, president. Sure, 5 only. Okay. So 5. Uniqueness of values 5. Rows 14. 5 by 14. 5 by 14 means 0.143 are okay. 254 and 5 are 0.35 something will come. Okay, na? So now in this two, compare now. Which cardinality is low? Job. EMP number 1. So when a cardinality which is greater than or equals to 1, okay, which is greater than or equals to 1, this will be representing what now? High cardinality we called. It's representing high cardinality. And the cardinality which is less than 1, then representing what now? Low cardinality. Now, and high cardinality columns are preferable to create which index? B tree indexes. B tree index only preferable. Suppose you are asking doubt, sir, if I'm creating bitmap index on that high cardinality column means, okay, what it was happen? Uniqueness. All are having uniqueness. So each and every value uniqueness means uniqueness, every value you need to check. So there is no use of that. Okay, na? So, but the bitmap index on low cardinality, what happened? Only checking unique values, but in that what we have a duplicates are eliminated. You have a 1 lakh rows, but in 1 lakh rows, so duplicates are eliminating there. Every value is going to be eliminated. So then what happened? When number of duplicates are eliminated, automatically your uniqueness will be decreases. On the decreases of uniqueness cardinality, always low. When your column is not having duplicate values, then the cardinality high. Yes or no? Now EMP number, you have any duplicate? No. That's why your cardinality how much? 1. When job column you have a duplicate. Yes. Then what is your cardinality? Low. So when your column is having more duplicates, then duplicate columns cardinalities are low. If there is no duplicates in your column, then it cardinality very high. Okay, so on that high cardinality of column, bitmap indexes are not useful. There is no use. And if you created performance wise, there is nothing will be advantages for us. Okay, now, so that is the reason high cardinal. That means how to decide when you calculating your cardinality of a column, when it will be come to you greater than or equals to 1, then define it is a high cardinality. And high cardinality of columns are preferable for to create B-tree index to improving performance of database. But on this high cardinality of column, if I created bitmap indexes, database performance will never improve. Okay, but that means it's not a suitable method for high cardinality. Okay, now low cardinality means which is less than 1, then it will be treated as a low cardinality. On low cardinality of column, B-tree indexes are not suitable. That's why the people created what? Bitmap indexes. Okay, now bitmap indexes. So this is the way the real-time people, they will be decided on the column which method, that means which scan method, if they apply, then I will improve my performance of database. That how they knows means based on their cardinalities are first calculated, and the cardinality will be greater than or equals to 1, it will come, then the column is considered as a high cardinality of column. So then immediately on high cardinality of columns are preferable what? B-tree indexes to improving the performance of database. But low cardinality of columns, they will use bitmap index. That's why bitmap index definition also very clear. What is the definition? These indexes are always created on low cardinality of columns. So it's a defined, that means definition also given to create on low cardinalities only to improving your performance. Okay, so this is the way you can calculate your cardinality of a column. And what I'm saying here, greater than or equals to 1, it comes under high. Less than 1, it comes under low. Okay, now, so now this is the way you can calculate. And what is the syntax to create your bitmap index? Create bitmap index, and I want to give on index name on table name of a column name. Okay, now let me come. So now I'm creating my bitmap index on job column because it is low cardinality of column in this table. Now I can apply. So create bitmap index BIT on EMP of which one? Job. So my index is created. And if you want to see your index, so now you can see on job column, which index is created? Bitmap. Okay, fine. And after created bitmap index, what internally happened and how the data will be arranged by your system internally. Okay, na? Here observe. when we created a bitmap index object, a bitmap index object on a column, internally system, okay, will arrange that column data in the format of in the form of bit mapped index table, in the form of bit mapped index table with bit numbers, numbers 1 and 0. These are called bit numbers. Okay. And here observe, here 1 means what now? Here 1 is nothing but my condition is true. Okay. Here 1 is nothing but condition is true. And 0 is nothing but condition is false. Condition is false. Okay. Now we can see, suppose I'm going to calling one. Okay, I already created my bitmap index here. Now I'm calling with the summary codes. Select a star from EMP. Don't write for subserve mechanism. Where job is equals to, for example, I was given clerk. So whenever the user will send this request to server, based on this request, the server will send it to system, and system what it will do in your job column, okay, whatever the data was there here, that each and every value will be checked, and wherever the duplicates are there, the duplicates are eliminated, and where is duplicate is not there, that will be not eliminated here. Okay, na? And now that elimination, not elimination, when we did at the time of cardinality of column finding purpose. Now what it will do? Now once you created bitmap index object on this column, so duplicates are eliminated, distinct values are countable. Based on distinct values, it will be finding cardinality. That's over. After that, based on this column wise, which column? Cardinality column wise, if I retrieval my data, okay, then internally this column data, how the system will be arranged, means that the system will be arranged in the format of which format I said? Bitmapped index table format. And with what numbers? 1 and 0. 1 means what I said? Conditions will be true. 0 means what I said? Conditions will be false. Okay, let me see how internally your system will be prepared this. Bitmap indexed table. Okay, now we can come back. Complete scenario first, get it. Then you will get some idea. Okay, and this is my column. On which column you created your bitmap index? So I created bitmap index on job column. So job is a referenced column. It will take. Then in my table, how many rows? 14 rows. So 14 row numbers I'm taking. 14 row numbers. So first row, second row, Okay, so these are the 14 rows. Okay. Now, first condition, what I was given, job is equals to clerk, and your clerk will take clerk. Okay, clerk will be checking now. Check with clerk. First one, clerk is equals to clerk. Condition true or false? True. So true means when condition true, what is the bit number? 1. So like this, it will arrange. Next, clerk is equals to salesman. False. Clerk is equals to salesman. False, 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 false. How many next true? Which one true? First row is true. Then 9, 10, 11 true, 12 true, 12 true, and 14 true. What is this? 9, 10, 11, 12, 14. Okay. Remaining all are false. False means what? Zeros. Ten also zero na? 11? Huh? 2. 12? 13? 14? 1. Okay. So this is the arrangement of a bitmap indexed table. Okay, after that, what it was happened? After your system is going to be arranging in the bitmap indexed format here, then here wherever one is there, the one is called as a true conditional values. And here every one is representing here. Okay, otherwise below I'm writing. So what I'm writing here, here one is represented. Here one is represented. Okay. What now? Row ID in a table. Row ID in a table. So now one. So one is called as a row ID. So what is the row ID here? 1. So condition true. And your row ID based on this page number, based on this row ID, directly jumping to your first row. And first row immediately it will be take from your table. Like how I can say, if I know my required topic in which page number, then based on that index page number, can I go to directly jump now? Yes or no? Yes, same as here. Here one is representing row ID. What is your first row ID was there? Based on that row ID, it will go to directly your first row data and pick your first row. Okay, after picking this data, sending to client, what is remaining all are zeros. So wherever zeros are there, those 0 rows are not searching. 0 rows are not searching by your server. So next what it will do here 1. So based on row ID, first row will take it out. After that, what it was happened? Directly jumping to which row? 11th row. That means here 1 to 11 between how many rows we have? 3, 6, 9 rows. These 9 rows are not searched. User is not searching how many rows? 9 rows. Then 11, 11 after 12. Then this is not searching. Then 14. So that means what it was happened on the table? So as per your bitmap indexed table data, first row it will be taking. After first row, later directly jumping to where it is here, 11th row. Then directly jump 12th row. Then directly jump 14th row. So that means in between, the year to year, these rows are not searched by your database server. So out of 14 rows, how many rows are not searched? 10 rows. That means here 10 rows means each row will take 1 second of time. Then 10 into 1 is equals to 10 seconds of time is what? Saved. Understand? Na? If you are not created bitmap index, then how many rows are searching? 14 rows. What is the time? 14 seconds. 14 seconds time taken. But here, if I applied bitmap index here, how many seconds? Only 4 seconds. That means remaining 10 seconds of time is saving. Because I'm not searching 10 rows. I'm not searching 10 rows means that 10 into 1 second for each row, then 10 seconds time we are not search. It means indirectly 10 seconds of time is saving for customer. Understand? Na? That is what the bitmap. Suppose if I'm asking the next one, here my condition will change now. What is my condition now? If I was given what now? President. Okay, now? Yes. When I was given president, okay, then president will be, the president column will be arranged now. Now come out. In the president, where you are president? Here. Which row? 9th row. So first row, president is equals to clerk. True or false? False, 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 false. Next, true. Which position? 9th position row. After that, remaining all are false. So now we can see then what it was happen. 0, 0, 0. Next, 0. Next, 0. 2. Next, false. Next, false. Next, false. Now here the president. Now it was arranging by your system, and after based on this indexed information, server will directly go to which row? 9th row. Why? Because in the 9th row only condition will be true. So that means your server, Oracle server, will not searching. Your Oracle server will not searching. Okay, will not searching first row to 8 rows. These rows are not searched. Next after 9, 10, 11, 12, 14, not searching. So your Oracle server as per this condition directly go to 9th row because of reason 9th bit number is 1. So based on this, it will go to where now? Table. In table, 9th row, wherever it is there, directly jump to 9th row and retrieval. So that means here, how many rows are not searching? 13 rows. That means how many seconds? 13 seconds of time. Saving or consuming? Saving. Okay, na? 13 seconds time saved. But if I'm not created indexes for this, only for this condition purpose, how many rows I need to search? 14 rows. 14 rows means how many seconds? 14 seconds. So 14 seconds and your 13 seconds save. You're taking 14 seconds time, but you're taking only 1 second of time. Remaining 13 seconds are saving. But your 14 seconds are wasted. 1 second is advantage, saving. Okay, na? So now 1 second we are getting our information within 1 second. But here we are getting 14 seconds. Within 14 seconds, we are getting that information. So 14 second getting information is a better choice, or 1 second you will find your data better choice. 1 second we find your data better choice. Otherwise, another way. 14 seconds of time are you wasting on your data, or 13 seconds of time saving on your data? Which one is better? Wasting or saving? This is another method. So analysis can be in any way. You can see time saving level also, index is better. Fasting level also, index is better. Fasting, how much faster? 1 second is very faster. Data is very fastly retrieval here. But here, how many seconds retrieval? 14 seconds, very slow. So this is what a retrieval fastness, quickness. How much fastly index is retrieved, your required data, how much solely without index is retrieved. You're retrieving data 14 seconds. You're retrieving data 1 second. This is one level. Otherwise, your expenditure of time 14. Your saving of time 13. This is another level if you can compare. So both side comparison, searching level comparison, retrieval level comparison, both side, which is advantage, indexes are advantages. Okay, na? So this is what we called as a bitmap indexes are how internally system will be preparing, and wherever zeros means condition where false, and false conditions are 0, and 0 rows are 0. Suppose second row is what now? 0. Then your server will not go to second row. Second row will not touch, because second row is a 0. Yes or no? That means it doesn't go there and it doesn't touch that. Okay. Wherever 1 is there, 1 rows only touch. Remaining 0 rows are not touch. So automatically time save. Right down below. And now take from the starting onwards, bitmap index. What are you discussing here? From starting class onwards, I observed. No notes, no writing, writing. In front of me, you are sitting and talking to each other. Very serious topic. India match loser. That is a topic. Otherwise, Mahesh Babu cinema flop. That is a talking. Then, what are you talking here? Job. Job talking. Job also not talking. That means girlfriend. Yes. See. Girlfriend. No, no. See, your friends are commenting on you. Actually, Naresh is conducting off campus something. Yes or no? When it is? I'd say. You don't see my face here. If you see my face, will not come any answer. When it was? Date, any date was mentioned in that? No. But almost they will taking on all SQL also they're taking. Yes or no? SQL and PLSQL. Good packages. 3 lakhs package. Yes or no? 3 lakhs, But when the data, okay. When the last day of registration? November 3rd, tomorrow. Tomorrow means then later they will conduct. Registered, which technologies? One is SQL, one is Oracle PLSQL. Next, SQL Server, Oracle PLSQL. Next, DevOps, Python, DevOps. No. Angular, Android. Next, DevOps. DevOps also there. AWS is there. AWS. Total how many technologies? 4 or 5. All are tomorrow last day. Registration. Before? See, why you people are this much negligence here? If any drive information come to you, perfectly you know the drive, when, what, and if you have any doubt, immediately contact to Naresh Shetty people. Okay, the admins are there now outside. What are their works? Admin work is what now? Room is cleaning or not? Chairs are arranged or not? Mic working or not? System is keeping or not? Any student getting any problem here? Any facility you wanted? Okay, or Naresh Shetty going to sending any information? This kind of works, they will do it. Any drive campus, Google Classrooms, those are the people, the responsibility. Okay, if you are not understanding the drive, when, where you are not get any clarity, go and ask him. He will give some information, maybe. He doesn't know, he will call to management people and he will get some information and they will pass you. Okay, no? And if anybody interested, almost SQL is we end. Maybe in this week, your SQL is close. So SQL Server, SQL is there, no? Attend, no problem. Same concepts, everything same, but syntactically difference. So that is not a big matter for the companies. They will teach you, okay, they will train you what is what. If you are interested on SQL, 3 lakhs package, if anybody interested, try it on SQL Server. And PLSQL is not completed, so you didn't go for that. And maybe next week onwards, I started PLSQL. Okay, no? Right. But SQL is there. If anybody interested, they're trying to database side, you can join and register on SQL basis and attend that interview process. Oracle SQL, SQL Server SQL. Okay, both positions you can apply, no problem. Okay, but when you're working level, they will train you what is the difference of SQL Server and Oracle. The small differences they will tell you. If you catch that, then you will be continue that process. Okay, it's not a big tough to us. Okay, but I said already, SQL standard queries are same. DDL queries, DML queries, DQL, TCL, and DCL. These are the standard queries. These are the common in any database. But remaining will be change. Data types are change. Operators maybe little bit changes. Functions are having some little bit changes. And syntactical joins some little bit changes. Okay, now. So this is what it was. Very minor differences are there, not a major. If you have a major, I'm saying that don't register. If it is a minor, so that's why you can handle, you can register that also. Okay, na? So try it, maybe your luck. If you are interested and you got a placement on SQL developer, 3 lakhs package, very well. And once you enter into your company, as per your experiences wise, you will be get your promotions. But database developing position also, programmer position also, very good in the market. So I'm working last 10 years as a database programmer. Okay, na? I don't get any problem in my career. Very happy, smooth job, database job. I don't have any tensions like Java students, .NET students. Java .NET programmers are 24 hours a dilemma because I understand highly coding, lot of coding they want to write. Okay, now that's why those are very tough jobs. Java developing, .NET developing is not easiest, very toughest jobs, and have a more demand in the market. Okay, more vacancies on that. So definitely when high level coding is there, definitely pressure also very high, very complications to handle the coding part. Okay, that I can understand that. But database developing job it's a smooth job. Cool, your job will be slowly. Huh? Nothing was happened. Calm going work. Okay, na calm going work. Java development, how you know Java developers are interacting. Yeah, oh. Database people calm going. No noise. Nothing will be there. Happy job. But you have a skills and later extend your topics one by one. Okay, na? Then career will be long time. And this kind of offers also come to you in between. If you wanted more money to earn, Amirpet institutions calling, sir, can you come and take 2 classes? We will pay this much per candidate. This is additional benefits for software trainers. Okay, na? So multiple packages. This package, that package. Enjoy, na? Happy, na? When you have a proper planning. Hmm? Right, those jobs, SQL same, almost equal. You can try, and SQL we finished here. Okay, almost we end and one more, 2 more topics are there. So that maybe tomorrow and day after tomorrow I finish that. Then after you can easily, you can attend your SQL interviews. Okay, now happy letter, no problem. Confidently, same topics, definition is same. Okay, now if any interview person asks a definition, syntax write down. In Oracle syntax only write down. Okay, they can understand that. Okay, now write like that. Complete this notes, complete first. Okay, completed. Huh? Mm. So these are bitmap index arrangement of data. So which format it was arranged means in tabular format. And this is the way of arrangement of bitmap and bit numbers, either 1 or 0. These are called as bit numbers. Okay, now? Right. So these are the two types of indexes in your Oracle, but generally these indexes are created by database administrators, not developers. Admins are applying these indexes on their table columns. Okay, first they apply and later they will send it to you front-end people, and they was using those tables to data retrieval, accessing as a fastness or a quickness. Okay, no? So these are the two types, and database admin side people, this concept is important. Okay, instead of developers, but developers also little bit idea, if you have it, it's better for you. Okay, right. And now after we have some data dictionaries are there that I will discuss tomorrow, and tomorrow it will be completed this indexes. Later two more concepts are there, three more concepts are there. One is clusters, normalizations, and user defined data types. This three after we enter into PLSQ. Okay, now? Right, yes. Thank you. Thank you so much. And online students have any doubts, send your doubts. Rohit, you can apply the after completion of this course SQL developer position or PLSQL developer or Oracle developer positions you can apply. Okay, now? Right.